Have you ever wondered about how underwater pipelines stay hot? 1. But what engineers found hidden inside the pipe changed everything. The ocean floor is near freezing, turning oil into sludge. Imagine wrapping a hot coffee mug in thick winter foam. Special polymers trap heat, keeping the oil moving perfectly fast. We use electric heating wires to keep the flow warm. Sensors detect temperature drops before a single clog even forms. Nature tries to freeze it, but our heaters win today. It is a silent battle, won by physics and smart design. What other hidden dangers lurk deep below the dark waves? At 3,000 meters, the ocean is a freezing tomb. Hot oil meeting icy water creates a thick, waxy nightmare. These pipes are the veins carrying energy to the surface. Think of this foam layer like a thick winter parka. It traps precious heat, keeping the crude oil flowing freely. Pressure here would crush a submarine like a soda can. Materials must withstand immense weight without losing their thermal edge. When insulation fails, we use electricity like a heated blanket. Engineers call this flow assurance, ensuring nothing ever stalls out. But what happens when the pipes themselves start to leak? At 4 degrees Celsius, oil turns into thick, unmovable sludge. Engineers wrap these pipes in thick, high-tech synthetic foam jackets. Think of it like a giant, industrial-strength thermos for oil. These microscopic polymer beads lock heat inside the steel walls. Cold oil deposits wax, which acts like cholesterol in arteries. Special chemicals are injected to keep the oil flowing smoothly. Some lines use electric heating wires to stay perfectly warm. It is like a heated blanket for a massive metal snake. This complex insulation is the only reason energy reaches us. Wait until you see how these pipes handle crushing pressure. Deep sea water sits near freezing, turning oil into sludge. Engineers wrap pipes in thick foam to trap internal heat. Think of it like a giant, reinforced, underwater thermos bottle. Advanced polymers act as microscopic blankets for the flowing oil. If heat drops, ice-like hydrates form and choke the pipe. Some lines use electric cables to actively warm the fluid. It is a race against time before the cold wins. Peeling back, the layers reveals a complex, multi-material metal sandwich. Maintaining this warmth is what keeps our global energy flowing. Frozen water surrounds these pipes, stealing heat every single second. Cooling oil turns into thick wax, clogging pipes like cholesterol. Engineers wrap pipes in thick foam, like a giant winter coat. This dense plastic keeps the warmth trapped inside the steel. Deep sea pressure is immense, constantly trying to crush insulation. Small gaps in the coating could lead to total system failure. Passive insulation works silently, needing no power to keep heat. It is essentially a giant thermos running across the seafloor. Keeping the flow moving is the only way to survive. Thick layers of polyurethane foam trap the oil's natural heat. This synthetic foam acts like a high-tech thermos for miles. But when flow stops, engineers activate a hidden electrical system. Powerful electric currents surge directly through the steel pipe's walls. The metal resists this current, warming the oil from within. Hit the subscribe button and press the bell icon to get updates. This constant warmth prevents heavy crude from turning into wax. Massive subsea generators supply megawatts of power to this grid. Electricity and insulation defeat the crushing, freezing deep ocean currents. Frozen oil turns into thick sludge, blocking the entire pipe. We wrap pipes in vacuum jackets, just like your thermos. This trapped air stops heat from escaping into the ocean. Special chemicals are injected to keep the oil flowing smoothly. These additives prevent wax crystals from sticking to pipe walls. It is like adding antifreeze to your car during winter. The heat stays inside, ensuring energy reaches the surface safely. Engineers monitor this balance across miles of dark ocean floor. But what happens if the power to these systems fails? These smart heating systems work together to fight the freezing cold. Fiber optic sensors track temperature changes along the entire line. Computers on the surface instantly adjust the pipeline's electric current. It's like giving the giant pipe its own nervous system. If flow stops, heavy insulation holds heat for several days. Chemical barriers prevent thick wax from blocking the cold pipe. This constant warmth keeps global energy flowing through dark oceans. Thick insulation layers dwarf the divers who maintain them. The evidence points to a much deeper story.